So let's get started. And I have tried to make this one a bit more homeworky, like so you do some actual work in the beginning. And do you want to go? Do we go down again? I think maybe we'll just go down. So yeah, so please upload the latest BBC archive. This updated literally 4 minutes ago or something. So I thought what we should maybe do first is play with this notebook, and maybe we'll spend a little time trying to create a simulator that produces a mixture of two random graph models, right? We just did this little mixture of two Gaussians yesterday we were playing with, 037B, I think, and then the animal name one. So this one is like the other fundamental structure we want to understand, right? Strings, numbers, and random structures. So what I did here is just to get you started, so I'll kind of walk around. And so I basically pulled this graph generator code from Apache Spark's GitHub repo for GraphX. You could also check out this one, the graph frames one. But let's start with this first. So it's just literally the code, so you don't have to evaluate it, but just to see how a log normal graph is generated. So do people, so you know what a degree of a node is, right? So, okay, the graph basically is nodes and edges. We've seen this. A degree is just the number of edges of a particular node, right? So if it's undirected, it's just the number of edges. If it's directed, you have an out degree, which is the number of out edges, and in degree, which is the number of in edges. So a lot of random graph models fall in this class called, where they can be specified by the degree distribution. So that means if I simply look at the distribution of the degrees of all the vertices, they will satisfy some random variable, right? So our normal random log normal graph, so log normal is the random variable that is the exponential of the normal, right? So it's a nice thing because you can get positive non-negative numbers, positive numbers. So you can use the log normal distribution to specify what the degree distribution should be, and use the parameters of the log normal to create a random graph. So this is the full-blown RDD version of it, so you can make very large log normal graphs and stuff like this. So, and the actual code of how it's implemented is here. Including the simulation from the sample log normal and so on. Right. So and then there's another random graph, RMAT graph. So I don't really know the RMAT graph, but let's skip that one as well. Then there's this other one, grid graph. This one's what I want you to sort of use as the typical scenario. So we're going to have this normal or typical graph, and then we'll have this abnormal or unusual graph. So for the typical graph, normal graph, I want you to try using the grid graph. This is a lot simpler. It's deterministic, but still, so you can specify the grid size, number of rows and columns, and just produces a grid graph for you. I have simulations downstairs, so you can quickly see what it does. And then I want you to mix that, say 1% with the star graph, okay? So it's a very simple baby example. And later on, we can go all out, and as we understand more random graphs, we can complicate this mixture simulation, okay? So you don't need to even evaluate this. What you can do is simply, because I'm basically pulling you the code from here, so you can simply import graph generator utils and some literals and so on, and graph frames. And now I've made a grid graph, with a 5x5 grid graph. Okay, so I'm converting it immediately to graph frames because what we want to do eventually is set up this file stream, and then we will come back to the structured streaming in a different notebook and try to read in graph frames of network time series. Because graph frames, remember, is the community package instead of GraphX, and it gives us the SQL. So at least some YouTube videos I watched last night, I couldn't dig the notebooks out. They say that you can do structured streaming with graph frames. Okay, so we'll have to, and this is quite related to your project. Okay, so that's all this is. Okay, so then I'm simply adding some weight one because remember we have this little thing we've been using from the Wikipedia clickstream stuff that we've been carrying around. So I just want to run this guy so we can have some little visualizations. Right, so this is going to be my my little, what is it? A grid graph, right? It's just a 2x2 grid graph. It's in some projections. So you can lay it on the plane if you want. Okay, so here is the star graph. So this is the other one I want you to mix. So you can specify how many you want in the. It'll always have 0 as the center of the star, and you can specify how many vertices are there. So we can make this, because in a grid graph you typically have 1, 2, 3, 4 neighbors, and so we can make this a bit extreme, like a 10. So the idea is we have a 5x5 graph, a grid graph, and then we increase that too. And then we have a star, it's a big burst. So it's kind of a La La Land simulation, right? We're going to say there is some little, in the network security complex, maybe there is something that's snooping the network, and if it does it, we want to find that pattern, right? If it's scanning or whatever.
It doesn't compile from.
Oh, it doesn't?
Getting a reference to graph generators is
But graph frames package, right? Do you have the graph frame package?
No, for me it says object graph frames is not a member of the package or command 5.
So right, but do we have command 5? Right, let me see. Right, so basically, does this work for you?
No, that one is the one that gives an error.
Okay, remember we need to put the graph frames package, right?
Mm-hmm.
So I don't know if you go to your cluster and look at this thingamajig, just the libraries, I think. The libraries, yeah. So okay, about 17 libraries, but you should have graph frames here. See graph frame 0.5. Do you have this?
No, nothing.
So we did this right. Yeah. Yeah. So
for me, the command line is not running because graph generators is ambiguous.
Yes,
so it's imported from 2 places.
Oh right. Did you evaluate the first cell?
Yeah.
Oh, don't do that. Sorry. Should have commented it, but then the color disappears. I said that. Yeah, because I just put that there so you see what the code is that you're importing. Yeah. All right.
So how do I
just detach and reattach is the easiest. So yeah. But you know, I'm really forcing myself not to give you guys everything, so you click, 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 so this is good. Right. I should say. Or maybe I'll just comment it. See, then the color disappears, right?
Right, no, of course.
I mean, this is kind of how, this is not, you know, it's kind of how I mess with stuff, right? So, I mean, just basically pull the right code and then learn what's there. Yeah. Maybe I should just delete this cell. Okay, so okay, so now I think, yeah, try to follow the instructions, see if you can, right. Because all I did is just, I mean, I look at, so in a lot of these examples, you have this log normal degree distributed random graph, and that just comes from here. So I just, yeah. Okay. Okay, so yeah. So you're on your own, guys, so do your magic. You see, so this is kind of the task. So on something like 99% of the time, you simulate from the grid, and 1% of the time, you simulate from the star. So now you have to ask other interesting questions, like, are we outputting the edges into the file? How are we going to read later when we start streaming in this? Right? So you have to already think about how to read, you know, edges from a file. Right?
Can you just save it as the graph?
Can you save it as a graph?
Right, so there was this format for saving data structures.
Yeah, so you can just, because at the end of the day, that's why we put graph frames, so you can save the, you know, so there is a command to get the edges of the graph frame, right? So we're using GraphX to simulate and then convert to graph frames. And then we're going to essentially get the edges of that graph frame, and that can be written, right, for example, because that'll just be you can write it in many formats. You know, for example, you should be able to write in Parquet format, which is more efficient. We haven't read from Parquet yet, but figure it out. The other conceptual thing to think about is how are we going to, so when I say 99% of the time it's a grid graph, 1% of the time it's a star graph. I haven't thought this through carefully, so you know, we should try to think about what I really mean by this mixture. Okay. So are we going to, for example, simulate all the edges? I mean, are we going to look at it at the level of edges? Right. So in a 5x5 grid graph, how many edges do we have? Right. So, I don't know. So I used to know this. So in a 3x3 grid graph, How many edges are there? I mean, it depends on, I think this is what they do. Right, so on the boundaries there are 3. The interior there is 4. I think this is what they're doing. I don't think they have a toroidal. So this is the other thing physicists generally do, or even mathematicians. These are called toroidal 2D grids, right? So they make this a torus. So connect this to this. So, and this to this. I mean, that's for convenience, right? It's like the video game thing. So if you go left, you come back from the right. And so then when you make the lattice really fine, then you can ignore the boundaries basically. So a lot of grid graphs, especially in statistical physics, are in this form. Or you can just do a count the number of edges and find out what it is exactly they're coding, right? So I don't know, so we're somehow trying to, in the end, what we want to do is like to have a stream of edges coming at us, right? So let's say this is 0 and 1. I don't know how the naming convention is. And 2 and blah, blah, blah. So these edges could be sampled from this grid graph. This is one way we could do, So you could have the grid graph, construct the deterministic edge set, and make the star graph, construct the deterministic edge set. You could maybe join the 2 data frames, for example, I don't know, or keep them separate, and then sample from that edge sets, 99 and 1, right? That produces something else. So anyway, give you guys 10 minutes. Let me stop the stream.